All right, so today we're learning section 7.6, solving inequalities. You're going to notice that inequalities are very similar to equations, except they just have, they do have a few differences. The main difference is that you're not going to see an equal sign in these expressions. You're going to see inequality signs. Well, what is an inequality sign? We've got some examples here of inequality signs. Before we do that, I want to kind of jump over real quick to review inequality signs with you. I'm going to give you this one, this one, this one, and this one. And here's your choices. Greater than or equal to. Less than and less than or equal to. So we need to figure out which less than or equal to and then just less than. All right, so we need to figure out which sign matches with which statement. All right, so which one do you think is greater than? The one that's open to the left or closed to the left? Which one? First, second, or actually let's just number them. Let's go, this is number 1, this is number 2, this is number 3, this is number 4. All right, so which symbol is greater than? Number 2, very good. Which symbol is greater than or equal to? Number 4. We know that this bottom bar right here tells me that something is equal to. Okay? What about less than or equal to? Which number? 3 and less than 1. All right? So those are our inequality symbols, and we're using those to compare two sides, both sides of the inequality. The symbols compare them. All right, so now going back to example 1, here we're just graphing the solutions of inequalities, okay? So these are the solutions. I don't have to do anything to solve them. I'm simply graphing them on a number line. Okay, so we start with a number line. I want you to go ahead and write that first inequality, x is less than 2. We always read the variable first. No matter which side of the inequality it's on, we always read the variable first. X is less than 2. Write your number line. So the first number on our number line, or the middle number, is going to be whatever number is the solution. So in this case, it's a 2. The first number is going to be a 2 right in the middle. And then I'm going to fill in the numbers around it. Well, let's imagine this is, an actual number line. So if I'm going left on the number line, what happens to my numbers? They go down. So it's going to be 1 and 0. What happens if I go to the right? It's going to go up, 3 and 4. So now I've filled in my number line. Now I need to plot my solution. So my solution is 2, and I have two options here. I have a closed dot option and an open dot option. The open dot is used if it's just less than or greater than. The closed dot is used if it has the equal to part. Okay? So in this case, there's no equal to, so I'm going to put an open dot on the 2. And then the last step is to figure out which way my arrow goes. So again, read the variable first. We said x was what? Less than 2. So my arrow goes left for less than. And here's what this means. Okay? This is important that you understand why we're doing all of this. Well, with inequalities, there isn't just one solution like we have with equations. With inequalities, there's an infinite number of solutions. Tell me a number that's less than 2. Any number. 1. 0. Negative 1. Negative 3. Negative 600. There's an infinite number of numbers that are less than 2, right? So here's what the graph is showing me. The graph is showing me that this line continues on, but there's a cutoff. And the cutoff is at 2. Any number beyond that does not make the inequality true. What about 3? Is it true that 3 is less than 2? No. So that the 2 is my cutoff. And the reason it's an open dot is because, is it true that 2 is less than 2? 2 is equal to 2, but it's not less than. So that's why it's an open dot, because 2 is actually not the solution, it's just the cutoff. All right? So that just helps explain a little more of what we're doing here, graphing. We're showing where the solutions are on a number line. Let's look at the bottom right inequality. X is greater than or equal to 3. Number line, I want you to go ahead and fill in the number line. Which number goes in the middle? Which number goes in the middle? 3. What numbers go to the left? 2 and 1, and 4 and 5. Now, just like we said, it's either going to be open dot or closed dot. So if it's equal to, is this one equal to? Okay, then it's going to be a closed dot. And then my arrow, I've got to figure out, does it go left or does it go right? Well, yes it does. X is what? X is greater than or equal to 3. So here's what it's saying. All solutions are greater than or equal to 3. Well, which way would the arrow need to go in order to show numbers greater than 3? To the right. So that's why the arrow goes right, not nowhere. Okay? The arrow goes to the right, showing that all solutions would be greater than or equal to 3. That would make the inequality true. Now, what's different about the top one?
It's negative.
It's negative, and they're switched. You have to read the variable first. Say it with me. Read the variable first. Okay? That way you get your arrow correct. If you just read it left to right, you're going to get the arrow wrong on your graph. So, plot your solution in the middle. What's your solution? -2. Now, I want you to be careful. What happens to the numbers when they're negative? The farther left you go, don't say it out loud. I want you to try to fill in your number line. The farther left you go into the negative, what happens to your numbers? Go ahead and try to fill in your number line. What numbers go to the left? -3, -4, right? Because the farther I get from 0, the bigger my negative. And then to the right, -1 and 0. Open or closed dot? Open or closed dot? Closed, because it's equal to. It's got the equal to bar underneath, so it's a closed dot. And Xander, which way does my arrow go? Nope.
I meant right.
Read the variable first. X is greater than or equal to -2. All solutions greater than or equal to -2. Moving on to example 2. Now, in example 2, it doesn't just outright tell us what the solution is. We have to actually solve the inequality, okay? So there's just a couple steps here. The good news is that solving the inequality is the same process as solving an equation, getting the variable by itself on one side. So if I have d minus 2 is less than or equal to 1, how could I get d by itself? How would I get -2 to cancel to the other side?
If the d was a 0.
D can't be a 0. D just has to be by itself. I need to what, Mackenzie? I've got to add 2. Do the opposite. Whatever's connected to the variable. D minus 2, so I add 2 to both sides. D is less than or equal to, what's 1 plus 2? 3. Now that I have a solution, I can graph it. Go ahead and graph your solution. What number goes in the middle?
3.
3, very good. What two numbers go to the left? 2 and 1, 4 and 5. What'd you put? Open or closed dot?
Closed.
Why closed?
Because it's less than.
Because it's got that equal to. So it's closed dot. And then does my arrow go left or right? Why left? Because it's less than. And that's it. Let's look at the next one. X plus 2 is less than 6. Solve for x and graph your solution. I subtract 2 from both sides. X is less than 4. Open or close dot on the 4. And left or right? Who got it right? There you go. Okay, now on the third one, the variable's on the other side. No big deal. Make sure you read it first so you get the arrow in the right direction. Go ahead and solve. So what do I do to both sides? What do I do to both sides? I add 6. Very good. This is already subtracting. All right. Now, how do I read this? X is less than 18. See, if you read it, 18 is greater than X, you're going to try to draw the arrow to the right. It's not greater than. It's saying all solutions. X stands for all solutions are less than 18 to make the inequality true. So when you graph it, it's an open dot to the left. All solutions are less than 18. Do you see why it's important now? I see lots of people erasing. You see why it's important now? You've got to read the variable first. Okay? Whew. All right, one more example. You have it in you? Okay. Example 3. Okay. Well, sort of. It's 4 more problems, but I guess we're still on example 2. Sorry. Now we're still solving equations, except now what operations do we see here? What operations do we see here? Multiplication and division. Okay, so we just do the opposite and solve just like normal. I want you to go ahead and solve these two. So what do I do to both sides on the first one? How do I get x by itself?
You divide by 6.
What do you do, Malcolm? Yeah, divide by 6, both sides. Divide by 6, both sides. 14. Did you get 14? Who got 14? Raise your hand. No, Emmanuel didn't get it? No? You're kind of high and low today. You'd get it and then not so much. Okay, hang in there. Hang in there. All right, 14, 13, 12. Open or close dot? Closed, because it's equal to left or right? To the right. What do you do to both sides on the second one? Multiply by 8. Now it's going to be a really big number. That's no big deal. That's fine. What number goes directly to the left of negative 208?
209.
209. The farther I go to the negative, guys. Open dot and arrow going right. One more rule that we need to go over is when there is a negative attached to my variable. You see here that we have a negative attached to the variable in both inequalities. You see that? So my rule is I solve it the same way that I would solve an equation. What would I do to both sides on the first inequality? What do I do to both sides? What do I do? Divide by what? What? 3, but negative 3. Negative 3 both sides. And my rule says when I divide by a negative, I need to flip my inequality. So now instead of less than, it is greater than negative 6. Why? I'm not exactly sure the reasoning behind it, but the rule is if a negative is attached to the variable, this only applies to multiplication and division. Addition and subtraction, we just do like normal. Okay, even when there's negatives. I reverse my inequality and then I graph my solution like normal. Go ahead and graph your solution. Okay, so negative 6, negative 7, negative 8, negative 5, negative 4. Did you number it right? Did you get the numbers right? Okay, very good. Open or close dot? Open, arrow left or right? To the right. Very good. What do I do to both sides on the second one? Multiply by negative 3 both sides. Xander, what's going to be my answer?
Negative 36.
It is negative 36, but what's my inequality? Is it going to be greater than or equal to or less than or equal to? What happens to my inequality? I had to multiply by a negative. Anybody remember what I just said? What happens? I heard it. I got to flip it. Instead of greater than, now it's less than or equal to negative 36. Close dot, and it's going left. So when do I reverse my inequality? And I'm multiplying or dividing. When I'm multiplying or dividing and I've got a negative attached to the variable. All right, so we're going to break there. That's everything we'll cover for today. And we'll cover a couple more things tomorrow, just that will help you with your homework assignment. But that's pretty much it for 7.6.